Dear students, let's start our third lecture under Unit 1, which is Program Efficiency and Complexity Analysis. And this lecture includes algorithm definition and example. Once again, we'll get back to the definition and the time complexity and one example analysis. And coming to the algorithm definition, as we already learned, basically, an algorithm is a set of instructions or statements that guarantees an optimal solution in a finite interval of time. Here, after some interval of time or certain amount of time, an algorithm must guarantees a solution for a given problem. Now, basically, a good algorithm. While designing an algorithm, when can we say that whether it is a good algorithm or it is an average algorithm? Here, a good algorithm runs in less time or executes in less time, and also it will consume less memory space. But computational resources is usually more important. Computational resources, time complexity, for example. Now, coming to the factors which are affected for your algorithm analysis: hardware we used, operating system, compiler, size of input, nature of input, and the algorithm we used, and which should be improved. Here I said factors, right? So which one have to improve? Either a hardware or an operating system or a compiler or size of input or nature of input or algorithm. Here the algorithm is very important because once the logic is perfect, then one can expect an optimal solution for a given problem. Now, measuring efficiency. How to measure the efficiency? The efficiency of an algorithm is a measure of amount of resources consumed in solving a problem of size n. So here, how do we measure? Here we will measure basing on the time constraint, that is, how much time is required to execute a particular program or an algorithm, and also how much amount of space is required in order to execute a particular algorithm. So basing on these two factors or basing on these two measures, we are measuring the efficiency of a particular algorithm. And also there are some algorithms, for them we also need to calculate even the processor time also. Running time of an algorithm depends on generally the input size and the nature of input. Now, generally time grows with the size of input. If the input is more, then the time required is also more in order to process that particular input. Now, running time is measured in terms of steps or primitive operations performed. S by E. We will say S by E, steps per execution. Now, independent from machine or operating system, the algorithm, because here once the algorithm is designed, it is very easy to convert into any programming language, right? So here the programs are being executed in any of the operating system, whereas this algorithm is not depending upon any operating system. Now, how to find the running time of an algorithm or analyzation of an algorithm? Running time is measured by number of S by E or steps per executions or steps per operations performed. Steps means elementary operations like addition, subtraction, division, remainder calculation, etc. We will measure number of steps taken in terms of size of input. And let us consider a small example used sum of all the numbers in the array. So, as I discussed earlier, here a for loop where I is iterative variable I is initialized with 0, and now we check with the condition 0 is less than, let us consider n is equal to 5. 0 is less than 5. Now s is equal to, initially sum is 0, so 0 plus a of 0. For suppose a of 0 consisting of 1, okay, a array consisting of 1, 2, 3, 4, 5, and n is 5. So 0 plus 5 yields us sum as 5, and after that again we will check for the condition, because the I is incremented. Now I value will become 1 less than 5. Now the condition is satisfied. Again sum is equal to 1 plus again 2, 3. So likewise we are going to have our conditions Okay, and finally my sum yields me 1 plus 2 plus 3 plus 4 plus 5, sum of 5 numbers, which is 15, which is 15, and finally the sum S holds me 15, and that 15 is being returned by that particular algorithm. Okay, now how we have to analyze this here? How we have to analyze? What are the variables we have? S, I, N, A, right? So now initially I have sum is my algorithm name, and S is equal to 0. S is equal to 0. I had given some numbers, right? So here the numbers are given to some set of statements. Now initially which one will be executed? S is equal to 0, and that will be executed only for one time. And then second one is I is equal to 0. Even that will also be executed only for one time. Whereas I less than n, the check condition will be executed for n times, whereas I plus plus, even that incrementation is also done for n times. Now S is equal to S plus A of I, where I have the operations called assignment as well as the addition. Even these two are also for n times, and A of I, that one also for n times, and finally returning S, right? So that returning will be executed only for one time. So the numbered statements 1 to 8 will be executed only once, whereas the remaining all statements will be executed once per each iteration of the for loop, such that I'll be having n iterations. Okay, so a total of 5n plus 3 is my complexity. Now the complexity function for this algorithm is 5n plus 3. Now let's see the growth of 5n plus 3. For suppose n is equal to 10. 10 means I'll be having 53 steps. N is equal to 100. I'll be having 503 steps. N is equal to 1000. 5003 steps. 1 lakh. Then 50 lakh. 50 lakh 3 steps. As n grows, the number of steps grow in linear proportion to n for the function called sum. So now what dominates in the previous example? Here 5n plus 3. Here I have three numbers called plus 3 and 5. So as n gets large, now plus 3 is insignificant, or which is a minute value, and as a 5 is inaccurate, as different operations requires varying amount of time, so here I can even ignore the 5. So finally I can tell the fundamental, that is, it is the time for running this algorithm is linear in n, and finally we will write it as a big O of n. Likewise, the 5n plus 3 gets reduced to big O of n, and the big O of n is nothing but asymptotically we are saying the time complex. Those asymptotic notations we will cover in the next class. Now, let's have in summary the performance analysis. The performance of an algorithm can be measured by two parameters. One is the time complexity, other one is the space complexity. Now what is time complexity? Time complexity of an algorithm can be an amount of completed time to complete its execution. Here the amount required, the time required to execute a particular program or an algorithm is known as time complexity. Now the time complexity Tp taken by a program P is the sum of compile time and runtime. Now the compile time depends upon the processor which we are using, whereas the runtime is depending upon how we have implemented our algorithm or a program. Now space complexity of an algorithm is the amount of memory it occupies for completion of a particular algorithm. Now, time complexity. To measure time complexity, we have two methods. One is a step count method, other one is the operation count method. First one, step count. So here this method is used to count the number of instructions or steps that are used by a given algorithm to perform a particular task. So number of steps that are taken. Now the first step is to find S by E, as I said earlier, steps per execution or frequency, and also the frequency of statements. Now for executable statements, the steps per execution value is 0. For non-executable statements, the steps per execution value is 1. The way of measuring step count per execution are statements with no initializations are made with step count as 1. Comments, brackets, begin, end, braces for all the step count is 0. Expressions having a step count of 1. And also assignment statement, function invocation, return statements, all are having a step count as 1. Now let us see an example, sum of numbers in the given array, sum of the elements in the given array. So steps per execution, frequency. Frequency is nothing but number of times a particular statement is being executed. S by E can be either 0 or 1. Now total steps will be like multiplication of both. Now initially here the first one is a name. Name will not be considered for your for calculating your time complexity. So all are zeros, and even blocks also 0. S is equal to 0. This is an executable statement, so I have to give S by E as 1, and frequency is also 1, and by multiplying the first one and second one, I'll get total steps as 1. Now coming to the for loop. For loop will be executable statement. So S by E will be 1, and frequency is n plus 1. Why n plus 1? Because the condition will be checked for n plus 1 times, right? Because in the last iteration, as the condition fails, I will not enter into the loop. Means I am checking for the condition for n plus 1 time. That's why frequency is n plus 1. Total will be n plus 1 into 1, n plus 1. Now, and within the loop, whatever the statement I have, that statement will be executed only for n times. So now 1, n. Now return S, the return statement will be executed only for once. So it will be 1. And finally the total will be 1 plus n plus 1 plus n plus 1. So 2n plus 3 total complexity. And when we are saying mathematically, which is 3 will be ignored, 2 will be ignored, finally I will be having big O of n. Right? If at all if you are having any questions, you can mail me or you can write under comment. Thanks for listening. Okay. Thank you.